Back to the Stat 201 Beyond the Lecture video series. This is going to be lesson 2.8, which is about resistant versus not resistant summary statistics. That's going to be our big goal and our big vocabulary for this lesson is what does it mean for a summary statistic to be resistant, as well as which of our summary statistics are resistant or not. That leads us into our first big question of why does this matter? So the big part is if an outlier exists in our data set, then anything that we compute or calculate based off of our data might be influenced based off of whether that outlier pulls it in one direction or another. So we need to be careful in how we choose a summary statistic to reflect all of the data, including the outlier, or maybe we want it to represent all of the normal stuff that we see and we want to ignore the outliers. And so the other side of this might be that we've actually already calculated our summary statistics and we see something unusual, and so we might have to ask ourselves, was that summary statistic resistant or not? So that kind of tells me, was there something unusual in the data or not? And so that leads us into the definition of what does it mean for a summary statistic to be resistant? Resistant means that it is not heavily influenced by outliers. So if there's an outlier present in the data set, a resistant summary statistic might change a little bit if we included the outlier or excluded the outlier, but we wouldn't see any large changes in its value based off of whether the outlier was in the data or not. So that is the opposite of what it means for something to be not resistant. If something is not resistant, that means an outlier would change or could change our value a lot. So I'm going to take this time to go ahead and jump into an example. And our example talks about the McCutcheon House, a restaurant operated by students in the School of Hospitality and Tourism at the University of South Carolina. Guests are invited to enjoy a fine dining experience while supporting student learning. During 1 week, staff recorded the wait time, which is going to be our variable, in minutes for a selection of lunch reservations. To explore how certain statistics respond to unusual data, which are going to be our outliers, we will examine or consider three versions of the same data set. The first data set is the original data set with no outliers. The second data set is the exact same numbers, except for I change one of them to be extremely longer than the other, so we change it so it has one really big numbers. And the third data set is going to be the same data set with two unusually short wait times. So I'm going to go ahead and illustrate that with our actual data. So again, version 1 has no outliers. It starts at the number 8 as 8 minutes and goes all the way up to 22 minutes. And so you'll see lots of repetition, nothing particularly unusual in that data set. But in the second data set, what I do is I take that 22 and I make it really big and I make it 60 minutes. And in the third data set, I take the 8 and the 10, the first two numbers, the smallest ones, and I make them even smaller and I make them 1 and 2. So those are extremely unusual by comparison, which are all around 15, 16 minutes. So that being said, I take this data and I plug it into StatCrunch and say, hey, StatCrunch, what are the summary statistics for this? And so the first one I want to point out is the median, which is our measure of center, is 15 in the first data set, but it's also 15 in the second data set and in the third data set. So it doesn't change whether I have these unusual data points or not. You'll notice that the first quartile, which is Q1, is 13 in all data sets, and Q3 is 18 in all three data sets. So the first and the third quartile also did not change depending on whether there was an outlier present. And since the interquartile range, which is IQR, is calculated by the third quartile minus the first quartile, it's also resistant. It's all 5 across the board. So that being said, let's look at the ones that did change. Well, the mean, which is calculated based off of all of the data, does change. Now in the first data set, it's 15.4. In the second data set, when we have one really big number, the mean gets bigger. And in the third data set, when we have two small numbers, the mean got smaller. So that mean is going to change depending on which direction the outlier is in. You'll also notice that the minimum changes when we have unusually small numbers, and the maximum changes when we have unusually large numbers. Based off of that, the range, which is the difference between the maximum and the minimum, also changes. So the minimum, the maximum, and the range are also not resistant to outliers. The last one I'm going to talk about is the standard deviation. It's originally about 3.78. In both of the other data sets, it gets much larger, so an outlier will actually always increase a standard deviation. So it always gets bigger when there's an outlier present because it's measuring the spread of the data set. And so those four in yellow, the median, the first quartile, third quartile, and the interquartile range, are our resistant measures. And everything in pink, the mean, the standard deviation, the minimum, the maximum, and the range, are all of our not resistant summary statistics. So just to kind of summarize real quickly, our mean is not resistant. Our standard deviation is not resistant. The range is not resistant. The maximum and the minimum, as well as z-scores, because z-scores are calculated based off of the mean and standard deviation, those are all that are not resistant. Those are ones that are going to be influenced or affected by outliers. The ones that aren't affected by outliers, the ones that stay put if there's an outlier present, are our resistant ones. And so that's going to be our median, our mode, our interquartile range, and our first and third quartiles. Hopefully this helps you guys, and I look forward to seeing you guys in the next one.